Hello, Algebra 2. This is lesson 4.8, and today we're working with the quadratic formula and the discriminant. And you may be going, what? We're going to get to that. First of all, we've been solving quadratics with several different ways. The first of which was with graphing, where we learned to graph it and we found those x-intercepts. Then we learned to factor them, by setting those equal to 0, factoring them, and solving those two pieces equal to 0, which works great if it's factorable, right? And then we learn another trick. On some cases, we can take the square roots, and then we learn that we can take any quadratic and what we call complete the square. That's kind of a tedious thing, and do you remember the, b divided by 2 squared thing and all that? Wouldn't it be nice if we just had a formula that no matter what the quadratic is, we could just take the a, the b, and the c, throw it in there, and simplify it down, and boom, we can solve it. Well, that is what the quadratic formula was. And this brings me back to college because I did a speech on this. And so this works for any quadratic in this form. ax squared plus bx plus c. Now remember, we're going to try to take and complete the square on this. And in order to complete the square, I need this leading coefficient, the a, to be 1. So what I'm going to do is I'm going to divide both sides, the left-hand side and the right-hand side, by a. Because whatever a is, whenever I take a and divide it by a, it becomes 1. So I end up with x squared plus b over ax plus c over a is equal to 0, because 0 divided by a is still 0. I'm going to go ahead and subtract c over a from both sides and get x squared plus b over a x, purposely leaving space, is equal to a negative c over a. Now, this number right here by the x is my b, which in this case looks like b over a. So what I'm going to do is I'm going to say, make my number, I'm going to say b over a divided by 2. I'm going to square that. Now, dividing by 2 is like dividing by 2 over 1, which is the same thing as saying b over a times 1 over 2. Then multiplying that, that's going to be b over 2a squared, which is equal to b squared over 4a squared. So this is what I'm going to add to both sides. Plus b squared over 4a squared. And plus b squared over 4a squared. This left-hand side will factor into, remember, x plus what's in here before I square it, b over 2a squared, is equal to, and I want to get these with the same denominator, so I'm going to multiply this one by 4a over 4a. That's going to get me negative 4ac over 4a squared plus b squared over 4a squared. Because I want those same denominators. So the left-hand side is to the point where I can square root that, but we're going to give it just a minute. Combine those together. I'm going to write the b squared first. So b squared minus 4ac all over 4a squared. Now, whenever I take the square root of both sides, I'm going to end up with x plus b over 2a is equal to, remember to add in the plus or minus, the square root of b squared minus 4ac over 4a squared. Now I can put the plus or minus up top, b squared minus 4ac over the square root of 4a squared, which leaves the denominator to just be 2a over that same mumbo jumbo on the top, b squared minus 4ac. Then I'm going to subtract that b over 2a from both sides, and that's going to give me x is equal to, I'm going to write it first, so negative b over 2a plus or minus That's square root over 2a. And the same denominator, so I can go and combine that together. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And this is the quadratic formula. So if you have anything like this, ax squared plus bx plus c is equal to 0. Find the a, the b, and the c, plug them into this, simplify that down, and boom, you get x. So let's do that. Here we go. Let's just write that down. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's identify real quick. A is equal to 1, because that's a number right here. B is equal to 3, that's a number right here. And C is going to equal to negative 2, because if I want that to equal 0, I'd subtract 2 from both sides, making that 0. That's why the C is negative 2. So now let's plug all those numbers in. Negative b is going to give me negative 3 plus or minus. B squared is going to give me 9 minus, I'm going to run this out, 4 times a, which is 1, times c, which is negative 2, all divided by 2 times a. Continue on, that's negative 3 plus or minus the square root of 9 plus 8 all over 2. I said plus 8 because it's a minus 4 times a negative 2, so it would be minus a negative 8, which would be plus 8. And then x is going to equal to negative 3 plus or minus the square root of 17 all over 2. So this is what x is equal to. And we can just leave it just like that. If you wanted to, you could say negative 3 plus square root of 17 over 2, and negative 3 minus the square root of 17 over 2. That would be similar, and you could say, this is my solution set. But I don't like to write it this way because, well, it's just shorter. Let's try again here. Let's go ahead and regroup these. I'm going to subtract the 12x and add 9. So it gives me 25x squared minus 30x plus 9 is equal to 0. So now a is equal to 25, b is equal to negative 30, c is equal to 9. Plug that in my formula. X equals negative 30 plus or minus the square root of b squared, which is 900, minus 4 times a times c, all divided by 2 times a. Comes to be 30 plus or minus square root of 900 minus 900 over 50. And notice, 900 minus 900, this becomes 0. So it's going to equal to 30 plus or minus the square root of 0 over 50. That's going to be 30 over 50, which is just equal to 3/5. So x is just equal to 3/5. It's really nice when that discriminant, to throw a word out there, comes out to be 0. And then one more here. Let's try this. So I'm going to subtract the 5 from both sides, so I end up with negative x squared plus 4x minus 5 is equal to 0. So my a is equal to negative 1, my b is equal to 4, my c is equal to negative 5, x is equal to negative b, so minus 4, plus or minus the square root of b squared, 16 squared minus 4 times A times C, all divided by 2 times A. Negative 4 plus or minus the square root of 16 minus, let's see, 20, all divided by negative 2 is equal to negative 4 plus or minus, let's see, 16 minus 20 is going to be negative 4 over negative 2. Negative 4 plus or minus 2i, remember back to complex numbers, over negative 2. We can split that up. It'd be negative 4 over negative 2 plus or minus 2 over negative 2i. What's the 4 minus negative 4 divided by negative 2 is going to give me just 2, plus or minus 2 divided by 2, or 2 divided by negative 2 is negative I. Okay, and so my answer is just that. You can say 2. Since I'm saying the plus or minus of that, I can just say plus or minus I is what x is equal to. Now notice, if you were to graph these original ones, you'd see 3 different scenarios. This case gives us 2 real answers, meaning it crosses the x-axis twice. Whereas here, the vertex actually touches the x-axis right there at positive 3/5. And over here, it's opening downwards and crosses the y-axis at negative 5, so it actually doesn't cross the x-axis at all. So here I have 2 real answers. Here I have 1 real answer. Here I have no real 2 complex answers. And you can tell the difference by what's happening underneath this square root. If this square root comes out to be a positive number, notice that 17, then I end up with 2 real answers. If that number under here comes out to be a 0, I end up with just simply 1 answer. And if that number under the square root comes out to be a negative number, then I get 2 imaginary. And that brings us to this page. That number under the square root, the b squared minus 4ac, is what we call the discriminant. That's what we call the discriminant. Not discriminate, but discriminant. And this right here just summarizes what I just said. If that number comes to be a positive number, 2 real solutions. Negative number, 2 imaginary solutions, 0, 1 real solution. And so our instructions on this are simply find the discriminant and then state the number and type of solutions. So these are already set up in the equals to 0 for us. I'm going to go through these fairly quickly with the video actually paused because this is getting pretty long. So I get negative 4. Since that number is less than 0, I have 2 imaginary solutions. On this one, I got 0, which means I'm going to have 1 real solution. This time, notice I got 4, which means it's positive, which means I have 2 real solutions. So feel free to pause the video and look back through any one of these if you're trying to figure out how we did that. I like to do this step first because I don't have to calculate that number anyways. Makes it easier whenever we are calculating the whole answer, and then I know if I'm supposed to end up with 2 imaginary, 1 real, or 2 real solutions. Your homework is on page 296. You're going to do 4 through 20s even. You're going to do 32 through 48 even, and then 2 from the review.